Please take a look of those cheat codes and pause the video to copy and save them for later.
Alright, yeah, I have a question, another question here for reservoir. Two reservoirs are connected by means of a parallel pipe 625 meter long. Take note of the diameter. The first half of the pipe has a diameter of 150 millimeters, and the second half has a diameter of 75 millimeters. The surface of the water in the upper reservoir is 30 meters above the level of the water in the lower reservoir. Tabulate the head losses which occur, including that at the shaft-edged entry, and calculate the flow of water in liters per second. Take F is equal to 0.01 and head loss at the entrance of pipe 0.05 V1 squared over 2G. Meaning that we're going to experience something like this. You see, this is that is the data that I've taken, but now we need to analyze the object first. Remember that now, because we know that we have to have something like this. This is 30 meters. Remember, then here we have number 1 and number 2 and number 3, meaning here is at the contraction. The loss that happened at the contraction means the loss that happened at the change of the shape of the pipe. So the pipe changed from big to small, meaning we have the loss at the contraction, big to small. And we remember what we did about big to small. You're gonna go back to this guy and this guy. So meaning that this question says that we have the loss at the entry plus the loss at contraction plus the loss that happened at the exit plus what? Frictional loss. Frictional loss. Because what happened, they say that this is a sharp-edged entry. Sharp-edged entry. So meaning if there is a sharp-edged entry, we're going to have HL1 plus, meaning at the entry, HL2 at the contraction, plus HL3 at the exit, plus HF. This is how you're gonna go about. This is our boy. Meaning if this is our boy, we're gonna have a thing that we call it a head produce.
Please take a look of those cheat codes and pause the video to copy and save them for later.
Flow. Which means it's H loss. That's the meaning of H loss, a head producing flow. Meaning if we have a head producing flow, you're going to have 0.5 multiplied by V squared over 2G plus 0.5 times V squared over 2G. Remember this one was 1 plus V squared over 2G plus the Darcy formula. This is how it's gonna be, like this. And remember what we are looking for. We are looking for what? The flow of water in liters per second. Meaning that Q1 is equal to Q2 tank A is equal to tank B. The flow of water is the same. So meaning we're gonna have area 1 times velocity 1 is equals to area 2 times velocity 2. Meaning that we're gonna make one of the same subject of the formula, meaning that between V1 and V2, we're gonna make V2 the subject of the formula. So if we're gonna make V2 the subject of the formula, we're gonna have A1 over A2 multiplied by V1, meaning that we're gonna have D1 over D2 close bracket squared times V1. Then we're gonna have V2 is equals to remember we had the answers for, they gave us the diameters of diameter 1, diameter 2. So meaning that you're gonna have sorry for not showing that. So we have something like this. So already we know that we have this formula. So we will be able to calculate V2, because they say the diameter of one is 150 millimeters and 0 is and then it's gonna be 0.15 meters, because we're only working with meters here, not millimeters. Then diameter 2 is 75 millimeters, therefore it's gonna be 0.075 meters. Okay, so now we know we have the diameters. So now the diameters, it will be 0.15 over 0.075 is equal to squared over V1. Then V2 is gonna be 4 times V1. Then remember that we had what? A head producing flow is equals to H loss. I remember when I say that this thing, and remember a head producing flow, they gave it to us, meaning that it's gonna be delta H is equals to H loss, and we know H loss, we have what? And remember they gave us 30 over 0.5 times V squared over 2G plus 0.5 times V 2G plus V squared 2G plus 4 times F times L times U squared over 2GD. You remember that. This is how it's gonna be. The cheat code. Okay, let's do it. So now remember that here we have 2 diameters, so that we're gonna have another HF for diameter, because here we're gonna need to include diameter of pipe number 1 and another HF for diameter number 2. So it will be like this. You see it? Yeah. So basically this will be like 0.5 times V1 squared over 2G plus 0.5 times 4 times V1 squared over 2G plus 4 times V1 squared over 2G plus, I see, 4 times 0.01 times, what was the distance? The distance, you're going to divide it by 2, so 625 divided by 2, it will be 312.5 times, 4 times V1 squared all over 2 times 9,81 times the diameter of the first thing is 0,15. Then we close it. Then after that we go up. Then after that we're gonna see plus 4 times 0.01 times 312,5 times 4 times v squared all over 2 times 9,81 times 0.075 close. Then that is equals to how much? Meaning that this thing I'm gonna calculate it. So meaning I save time so that I calculate all of the answers. So meaning that it's gonna be like this. Remember that this 2g is gonna be 2 times 9,81. So yeah, already a bit of a mistake. So if you don't understand, you can ask on the comment section. I'll explain better to you again. So remember that this one, it was for v1 and that the v1 is 1, so this is gonna be v1 squared only. So meaning we're gonna have 1 here, you see. But remember this one is for v2, whereas v2 is equals to this. So that we got this all answers. So for this one we get 0,02548 v1 squared plus 0,4077 v1 squared plus 0,8155 v1 squared plus 4,2474 v1 squared plus 135,9157 v1 squared. Meaning that our answer for this side is 141,4118 v1 squared. Then after that we know we need to make v1 is substitute the formula so that we can get what is v1. So definitely we get our answer for v1 as 0.4606 watt meters per second. Then therefore to get the flow of water you're gonna have area 1 times v1, where it's gonna be pi 4 times 0.15 squared times 0.4606 is equals to, then we do our calculator, pi over 4 times 0.15 squared times 0.4606. Then definitely our answer will be 8,139 times 10 to the power -3, meaning therefore Q is gonna be 8,139 liters per second. Meaning this, if it's like this, it was gonna be meter cubic per second. So we get our answer correct.